Hi everyone, we're starting section 4D in your textbook on the division by radicals. So we've looked at addition and subtraction, we've looked at multiplication, and we're now looking at the last section, which is division by radicals. Now, when we divide by a radical, what we're always trying to avoid is we don't want to see radicals in the denominator. We don't want to see square roots in denominators. It's just something that we don't normally leave in there. So what we do is that when we have to divide by a radical, we multiply both the numerator and the denominator by the radical that is found in that denominator in order to get rid of that root, so that we end up with an integer or a whole number answer. Alright, so what does that mean exactly? If I were to have, for example, let's take the example that we've got here of 4 over root 2. Now, if I were to multiply the top and the bottom of this fraction, so the numerator and the denominator, if I were to multiply them by root 2 over root 2, it would be as if I were multiplying by 1. So I'm not really changing the expression in any way if I'm just multiplying by 1. But by doing this, though, by multiplying by root 2 over 2, I am enabling myself to get a whole number answer in the denominator, because then when I multiply 4 times root 2, that gives me 4 root 2, and then root 2 times root 2 goes to 2. So therefore, I have gotten rid of the square root in the denominator. Now, because the square root is gone now, I can actually eliminate the 2 and the 4 that are up at the top, and I'm left with an answer of 2 root 2. Or, if you want, you could leave it as 4 root 2 over 2, as I left it down here, but the simplified form would be 2 root 2, where my whole number answer, or my integer answer, in this case would be 1 in the bottom, or 2 if I don't simplify it. Alright, so let's move on to a couple of other examples. So if I wanted to write with an integer denominator, integer means a whole number denominator, so I want to have a whole number, I don't want to have a square root. So what I would do is I would multiply the top and bottom by whatever my square root is, so in the denominator. So I will multiply this by root 3 over 3. The second one would be multiplied by root 5 over root 5, just as the third one would be multiplied by root 5 over root 5. And I'm going to wait a moment for this last one. So let's just very quickly do the first one. So that would give us 5 times root 3 is 5 root 3 over 3, which can't be simplified any further. 3 and 5 don't go into each other. And then I would have 4 root 5 over 5, which also does not simplify to anything else. And then I would have root 15 over 5, which also does not simplify to anything else. Now, in the last example, I could multiply the top and bottom by 2 root 3 over 2 root 3, but there's really no point in doing that because I just want to get rid of the square root. So I could still multiply just by root 3 over root 3, and that'll just give me root 3 over 2 times 3, which is 6. So it would be root 3 over 6. Now, if I chose to multiply by 1 over 2 root 3, and then I just take times 2 root 3 over 2 root 3, that is absolutely possible. I can just get 2 root 3 times 1 is 2 root 3, and this would go to 4 times 3, which gives me 2 root 3 over 12. But you see that my answer here now still needs to be simplified, and when I simplify this, it goes down to root 3 over 6, which is the answer that we had over here. So by multiplying just by the square root, and not by the whole thing, 2 root 3 or 3 root 3 or 5 root 3, I avoid having to reduce the fraction down any further. So my answer here would just be root 3 over 6. Now, if we have, though, a radical expression in the denominator, so that means that I don't just have a square root, but I have a 5 plus root something, or I have a 2 minus root something, and so forth, then what we do is, in order to get rid of the square root, we multiply by what is called the conjugate. Now the conjugate means the opposite sign, okay, that's in the middle of the expression. So for example, I'm just going to take the example that we have here, 2 over 3 plus root 5. Okay, so I've got 2 plus 2, oops, I've already forgotten. It's 2 over 3 plus root 5. So 2 over 3 plus root 5. Now, because I have a plus or minus in the denominator, contrary to what we had in the previous examples, we only had single radicals under there. There were no pluses or minuses in there. When we have a plus or minus, we're going to multiply by the opposite, or the conjugate. So the conjugate means the opposite sign. Now the conjugate or opposite sign is referring to only the sign in the middle. And then I'll just give you an example of something different. So I would multiply the top and bottom here by 3 minus root 5 over 3 minus root 5. Now, you may be asking yourself, why am I doing this? Okay, the reason why I multiply by the opposite is because if you notice, I have created a difference of squares in the bottom where I have two identical binomials, but one is positive and the other one is negative. And if you recall what I've said in the past about difference of squares, the difference of squares gets rid of the middle AB term, and that AB term that's going to be disappearing is going to be the square root. So by multiplying by the conjugate, we're creating a difference of squares so that we can get rid of the square root in the denominator. So what we'll do then is we'll multiply 2 times 3 minus root 5. We will distribute that, and it will go to 2 times 3, which is 6, and that'll be minus 2 root 5. And then on the bottom, because it's a difference of squares, I will just square the first number, which is 9, 3 times 3, and then I will square the last number, which is root 5 times root 5, which is 5, and then I will subtract. There will be a negative or a minus in the middle, again, using the law or the rule of the difference of squares. And then we have 6 minus 2 root 5 divided by 4. Okay, now we would definitely simplify this further. We could take out a 2 in the top, which is common to both 6 and 2, so that we're left with 3 minus root 5, all divided by 4. And now because 2 goes into 4, then our answer goes to 3 minus root 5, all divided by 2. And that's the end of that answer. Now, I wanted to go over another example. Let's suppose we have the same question, 2 over 3 plus root 5, except I've got a minus 3 plus root 5. The only thing that will change for the conjugate here will be the positive that's in the middle. So I will be multiplying by negative 3 minus root 5 over negative 3 minus root 5. Okay? So that needs to be clear to everyone, that when we are multiplying by the conjugate, we are actually multiplying only the opposite sign is only going to be in the middle. All the other signs attached to the other numbers outside of the middle are going to stay the way they are. They remain as they are. So that this would go to negative 6 minus 2 root 5 over negative 3 times negative 3 is 9, and negative 5 times negative 5 is positive. Negative root 5 times negative root 5 would be positive 5. So this would go to negative 6 minus 2 root 5, all divided by 14. And all of that can be divided by 2. So it would go to negative 3 minus root 5, all divided by 7. Okay. Let's try a couple of other examples. So we have a couple of more examples here with 1 over 2 plus root 3. So if I need to have an integer denominator, that means that I want to get rid of the denominator with the square root in it. So I will multiply top and bottom by 2 minus root 3 over 2 minus root 3. Okay? So I will do 1 times 2 is 2, and 1 times negative root 3 is negative root 3. And then we will have here a difference of squares that's created, so that we will have 4 minus 3. And that it gives us 2 minus root 3 all over 1. Okay, so we'll do the next question, the next couple of questions, so that we have root 3 over 4 minus root 3. So we will multiply top and bottom by the conjugate or the opposite, which is 4 plus root 3 over 4 plus root 3. So top and bottom, again, it's like as if we're multiplying it by 1. We're not really making any changes to the expression. So that this will go to 4 root 3 plus 3, all divided by square the first, which is 16, square the last, which is 3, so that we end up with 4 root 3 plus 3 all over 13. Okay, let's move on to some questions that get slightly more complicated. So let's look at E, for example. We're going to multiply top and bottom here by 1 minus root 3, 1 minus root 3 over 1 minus root 3, so that we have 2 root 3. So again, we're going to have to FOIL here on the top. So it'll be 2 root 3 minus 6, then it'll be plus 1, and then minus root 3, and that'll all be divided by 1 minus 3. And that ends up giving us, now collecting like terms, 2 root 3 minus root 3 is 1 root 3 or root 3, and negative 6 plus 1 is negative 5, and that's all divided by negative 2. Okay, we normally don't like to keep negatives in denominators either, so if I bring the negative up to the top, that means that all the numbers or the expression in the numerator is going to change all of its signs, so that it would go to negative 3 plus 5, negative root 3, sorry, plus 5 divided by 2. And if we want to make it look a little bit nicer, we would say 5 minus root 3 all divided by 2, which means exactly the same thing. All right, I'm done. This is the last question that I was going to go through. Now, I have here a couple of websites that I would like you to complete these questions online from Regents Prep. I'll put this on PowerSchool as well. And I'd also like for you to read the following examples found on the link below for further support on help for simplifying radicals, adding and subtracting, and multiplying and dividing. And it's also going to be placed on PowerSchool. All right, that's it. Thank you.